Welcome back for tutorial 2, where we're going to be talking about the future climate scenarios used in the IPCC and CMIP6. And you've already used data from one of these scenarios when you were plotting the Earth system model data in the last tutorial and how it may change going forward to 2100 under a specific scenario. Now, to talk about these scenarios, we first need to talk about CMIP6 more broadly, or the Climate Model Intercomparison Project number 6, which is the most recent one of these projects. So this is a global project that uses different climate models to simulate and understand the system. And within CMIP6, there are over 20 distinct model intercomparison projects, or MIPs, each looking at different goals and processes, ranging from the response of a system to different forcing, like volcanoes and aerosol chemistry, the biases that our models may have, and evaluating those. But the ones that are most important for thinking about future climate are a set of experiments that come under the Scenario MIP project. And now Scenario MIP, like the name suggests, considers several scenarios that encompass what Earth's future may look like. The reason there are several scenarios is that human emissions change Earth's climate. We've already seen that today, so CMIP6 contains historical simulations that simulate the last 165 years of Earth's history when humans have been emitting and therefore forcing the system through radiatively active gases. And we saw in today's invited speaker talk that these models have to have human emissions included in them in order to capture the warming that we've observed in the Earth system over this period of time. If we don't include human emissions, then we don't get that warming signal that the Earth has exhibited. So human emissions are important, but future emissions are going to depend on choices that are made by the global community, socioeconomic and political choices. And this means that there isn't necessarily one set of emissions that we can say will happen going into the future. We have to have a set of scenarios that encompass potential futures. And CMIP6, for this purpose, defined the Shared Socioeconomic Pathways, or SSPs, which are a set of potential realistic scenarios for future emissions in global socioeconomic circumstances. Now, these SSPs differ in several ways. They differ in their amount and time distribution of emissions like greenhouse gases and aerosols, and they differ in their land usage. So as an example, I've plotted the emissions of carbon dioxide under 5 of these different SSP scenarios, ranging from a high emission scenario, this dark red line called SSP 5 8.5, to a low emission scenario, the light blue line called SSP 1.9. Now, there are forcing plots like this defined for each of the important greenhouse gases and aerosols, as well as for different land use components for each scenario. And you'll be talking more about how they are constructed in tomorrow's tutorials. But for today, I want to talk about some of the key aspects of these scenarios and highlight how they're named and how they differ from each other. So let's take one scenario, for example, called SSP 1 2.6, which is one that we'll be using today. Now, this first number stands for socioeconomic scenario number 1, which is a scenario called sustainability taking the green road. So it's a relatively positive outlook scenario where we create more forest land use and less pasture. The second set of numbers, 2.6, refers to the radiative forcing in 2100 due to greenhouse gases, in this case 2.6 watts per meter squared. So that's how these scenarios are generally numbered. We're also going to be working with a second scenario called SSP 5 8.5 today. Now that first number is now a 5, which denotes socioeconomic scenario 5 called fossil fuel development taking the highway. Unsurprisingly, the name suggests this is a more industrialized future scenario where there is more pasture and cropland and less forest. And it's got higher emissions. And so that second set of numbers, 8.5, denotes a much higher greenhouse gas radiative forcing in 2100 of 8.5 watts per meter squared. So now in this tutorial, you're going to be taking data from both these scenarios and comparing how they differ for their future projections.